Video 6 of Chapter 3. We're going to be talking about this concept called the coefficient of determination, which is also called simply r squared. Now imagine I have 12 popular candy bars here, and I know how many calories are in each of those candy bars. So we have a wide range, not really a wide range, but the minimum 100 grand has 190.5 calories, all the way up to what, a Twix at 286.1. So we know we're in the 200 calorie-ish range, depending on the type of candy bar that we have. And so my question is, if a new candy bar were to hit the market, then what is your best guess at how many calories it will have using this data? So if you know the min is 190, the max is 286, what do you think would be your best guess? And you might say, well, what about what's in the middle of all of this? Because that could be a really good guess. And that would be the mean, right? So if we could calculate the mean number of calories in these 12 candy bars, your best guess, your best mathematical guess, I should also throw in there, would be around 248 calories. Now, depending what's specifically in this candy bar, if it had some fattier stuff in it, if it had some sort of nuts or peanuts in it, it's probably going to have more calories in it than something that doesn't have necessarily peanuts or ingredients that are higher in calories. So your best mathematical guess would be 248 calories. Now, with looking at nutritional facts labels, I personally, this is just me, I personally look at the amount of fat after I look at the number of calories. So if I'm looking at this nutrition facts label, first I'm wanting to know how many calories are in this thing, and then the next thing I look at is how much fat is in this. Now, I've talked to students in the past that say not only do they look at calories, but if they are people who work out a lot or athletes, they're always looking at protein instead of fat. And then I've had students that say, you know what, I'm trying to cut carbs. And so I'll look at calories and I'll look at carbohydrates instead, which is all fair and fine. I'm just saying personally, I look at the amount of fat with the number of calories, and then I might go look at protein and carbohydrates. Now, the amount of fat does play a role in the number of calories contained in a candy bar. But is it the only factor that contributes to calories? And that answer is no. Sometimes at the bottom of a nutrition facts label, and this isn't always here, but it tells you at the bottom the calories per gram. And there are three main things in food that contributes to the total number of calories. And so for each gram of fat, there are 9 calories approximately. For every gram of carbohydrates, there are 4 calories. And for every gram of protein, there are 4 calories. So can I just use the amount of fat to predict how many calories a candy bar would have? Well, no, I can't necessarily just use fat because there are 2 other things that also contribute to the number of calories. So yeah, that was a question I just asked here. Do you think you could predict the number of calories a candy bar has just by using the amount of fat? And the answer is no. But how well does using the amount of fat in a candy bar predict how many calories it will have? So can we use fat to make predictions? Sure. But how great is it using the number of grams of fat as our explanatory variable to try to predict how many calories a candy bar would have? And so that gives us our idea of the day, the coefficient of determination, which is also simply referred to as r squared. So r squared is, you can think of it as the grade, if you will, that the regression line gets for predicting response variable values, y values, based on actual explanatory or x values. Now, we've used R before in this chapter, and that was our correlation, and that measured strength and direction of typically linear relationships. Now, you might be wondering, is the R in correlation and the R squared of the coefficient of determination, are they mathematically linked together? Is literally the only difference is that R squared is the squared version of the correlation? And yeah, that's the truth. If you knew what R was, all you would have to do is square the correlation, and there's your coefficient of determination. Easy. And if you knew what r squared was, could you simply just square root r squared and figure out what the correlation is? Absolutely, you could do that. So there is that mathematical relationship between correlation and the coefficient of determination. Now, the mathematical part of how r squared is calculated, you don't really need to concern yourselves too much with. But here's the short version of how r squared is calculated. So remember earlier when we said our best mathematical guess at predicting the number of calories in the next candy bar would be by just taking the mean? So if we said our prediction is the mean value here, if we looked at that 248 and we made it a flat line, because that would be our guess for every candy bar, right? So no matter how many grams of fat it has, we would always just say, we think it's going to be 248 calories. That's our best guess. And we can see all of these residuals, right? All of these vertical differences. If you can't see, here are the actual data points here. And those little vertical differences represents all of the residuals, how much error we had. Well, now if I actually figure out what the LSRL is of this data, and I look at all of these residuals, I can tell that on average that they're smaller than these errors over here. So we're going to try to figure out how much error were we allowed to kind of reduce using the regression line versus using just the average. And so you get these values called the sum of the squares about the mean. And what's the sum of the squares? What do we mean by that? Remember those squares we talked about in the last video? If we took all of these, that was a really bad square. That's rectangle. Come on. There we go. So if we took all these squared residuals and we added them all together, then all of those squared residuals using the average comes up to be this much squared error. Versus if we did all of these squared errors using the regression line, then we get this total squared error. And so overall, we get a reduction of a certain amount of error out of the total amount of error that we started with. And so our r squared value using fat as our explanatory variable is 0.3, roughly 0.3, or about 30%. So again, you will not have to worry about how do I actually calculate this r squared value. But this is how it's calculated. Nope, too fast. So what we would say is that 30% of the variation in calories, what we're trying to predict, y, is explained by the regression line, or can be accounted for by the regression line, using fat as our explanatory variable. So to flip this around, if 30% of the variation can be explained by using fat to make predictions for calories, then therefore 70% of the variation cannot be explained by using just fat alone. Which means where does the other 70% of the variation lie in? Well, it would lie in the other two things that we said calories are made up of, carbohydrates and protein. Now here's some other facts about r squared. R squared is strictly between and including 0 and 1. And again, instead of using actual values here, we could say it's between 0% and 100%. And literally r squared is the correlation squared. And then here would be the main thing to know. How do you interpret r squared? Once you have that percentage or that proportion value, the r squared is the percent of the variation in whatever y is, whatever you're trying to predict, is explained by the regression line using what are you using to make predictions? What is your explanatory variable? So just like we've been interpreting slope and just like we've been interpreting the y-intercept, this is kind of the third main thing that you will need to know how to interpret by the end of this chapter. So the last bit here says if carbohydrates are used to predict the number of calories instead of fat, then r squared is 0.35. What I want you to do is to interpret this 0.35. Okay, just like what we did with fat earlier, right here, could you, I don't know, interpret r squared when it's 35% for carbohydrates instead of fat? And then a secondary question I want you to explore is, what is the correlation coefficient, or what is the correlation between carbohydrates and calories? So again, remember correlation, that's r, and I gave you r squared. So I'll let you do the math to figure out that. And that is all for video 6.